So for question 2, we have passenger sitting in a train. So let's call this passenger Xiaoming. Okay, so Xiaoming is sitting inside a train, and the train is actually moving along a circular arc bending towards the right. So the train is actually moving in a circular motion that is moving bending towards the right. And as we all have learned in this chapter, for any object that is moving in a circular motion, there must exist an actual force that provides for the centripetal force. So perhaps in this case, maybe something like a lateral friction, okay, or some form of contact force that is providing for the centripetal force, okay. And in front of Xiaoming, there is a pendulum. So if the train is actually moving in a circular motion bending towards the right, I must also remember that the pendulum must also be moving in a circular motion, also bending towards the right, since the pendulum is part of the train, okay. And as I mentioned just now, if anything that is moving in a circular motion, there must exist a force to provide for the centripetal force. So in this case, what could possibly be that force? So we need to draw a diagram to show the forces as well as the position of the pendulum seen by Xiaoming. So let us understand, okay, there must be weight acting on the pendulum. But weight is pointing vertically downward. There is no way weight can be providing for the centripetal force. So the only possibility, okay, of a force that can provide for the centripetal force must be some form of tension. And in this case, the horizontal component of the tension, let's call that Tx, okay, must be providing for the centripetal force. So essentially, it is the horizontal component of tension that is providing for the centripetal force, which also means that the tension must be somewhat pointing towards the right. Okay, this help us, okay, come up with the position of where the pendulum should be. The pendulum must shift towards the left so that the string will be able to provide a tension that is rightward pointing, so that it is possible for the tension to actually provide a horizontal component to provide for the centripetal force. To give you a little bit more information, the vertical component of the tension, let's call that Ty, okay, will be exactly equals to the weight, because the pendulum is simply just executing a horizontal circular motion. So it is just moving along a level, horizontal level, just that it is moving in a circle. Okay, the position of the pendulum will not shift vertically up or down. So therefore, my Ty must be equals to the weight, just that it is pointing in the opposite direction. Okay, so that's about it. Let me show you the typewritten solution. So you can see here, the tension must be somewhat pointing towards the right, so that the horizontal component of the tension can provide for the centripetal force. So key thing, okay, is to remember, for free body diagram, we should never include centripetal force. Okay, to draw the free body diagram, it is simply tension and weight. Because centripetal force is actually a net force, a resultant force, and we never draw the resultant force in the free body diagram. Okay, so finally, I stress, in this case, it is the horizontal component of the tension that provides for the centripetal force.